All right, welcome to section 6.6, day 2 or part 2. We are going to do something called composition today. So in the previous lesson in 6.6, we added, subtracted, multiplied, and divided functions. Today we're going to learn something new, which is called the composition of functions, and generally just be composition of two functions. And a lot of this, the math is actually really easy. Adding, subtracting, multiplying, dividing, that part is not hard. The hard part is understanding function notation. All right, so like this is what one of the questions is going to look like. And I think it's hard for students to just make sense of what is that even asking. So one more time with function notation, when it says something like g of x equals 2x, our variables are x, and instead of y, it's g of x is our output. All right, and then what we do is g itself is not a variable to name of the function. So if we do something like g3, that doesn't mean g times 3. That means put a 3 in for x into the g function, and what do you get for an output? So if we were to do that, we could say the g function, when you input 3, gives an output of 6. Right, and as an ordered pair, we would say input 3, output 6. Okay, so understanding what that means is super important to this lesson, and generally just understanding the idea of a function is what you're going to need, right? So I can't stress enough, focus on the understanding, not just can I do this, but do I really understand what I'm doing in this section, and what does the notation mean? Okay, so going back to just a basic idea of what is a function, it's like an input-output machine. So this function is named f. It takes an input of x, and then it just multiplies that input by 2. So that if we do f of, say, 7, what that means is put 7 in as the input, and then do, what the function does is takes the input times 2, and so we get an output of 14. So we would say f of 7 equals 14. Okay, and we could do another one like f of 0 or something. We could input 0. So we put 0 in, and it do 2 times that, and we'd still get a 0. So our input and output are the same there. And then what's going to get weird in this lesson a little bit, and I'm going to show this to you the first time, but it's going to be pretty weird, is we're going to have another function, say g of x, and let's say that that is x plus 1. Okay, so far with f, we input like 7 or 0 or something like that. But we can also input into f, I ran out of space here, but we can input into f the entire g function. All right, so we can do f and then input this function. Remember, all that f does is double it. So what's going to happen here is it's going to take 2 times our input, right? That's what f does. And our input is g of x. So we're going to do 2 times the g of x function, which is 2 times x plus 1, because g of x is x plus 1. So we get as an output 2x plus 2, if I do the distributive property. Okay, so we essentially put in the g of x function here, which was x plus 1, and again it doubles it. The f of x doubles it. The f function doubles your input, and that gives you 2x plus 2. All right, and that's kind of the idea of composition, is you're passing in, instead of passing in a number to the f function, you're passing in a whole nother function called g. Right, and that's actually the hardest part of this lesson. So there'll be slightly different questions. So this one we did f of g of x, and we'll do slight variations that are a little bit easy here in a second. Okay, so another way to think of compositions is two functions that are strung together. All right, and so basically you're going to take, like if we have g of f and f of x, you're going to take the a number, put it in g of x, get that output, and the output will become the input into the second function, in this case f of x. Okay, so the easier type problems will look like this. They'll say f of g of, let's just take a number 2 or something like that. Okay, so what that notation means is we're going to start on the inside, and we're going to do g of 2 just on its own, right? So g of 2 on its own would mean put an input of 2 into the g function, and what do you get for an output? So we're going to take 2 into the g function, and it just adds 3. So we get an output of 5. Okay, so we evaluate the inside one first and say g of 2 is 5. So this expression now we could write as f of 5. Because g of 2 is 5, we have f of 5. Okay, so that 5 then, that becomes the input into the f function, and all the f function does is square stuff. So we're going to square the 5 and get an output of 25. So we get 5 in here, and then output is 25. Okay, so we would say, go back to the original problem, we would say f of g of 2 is 25. Right, so that composition of functions right there equals 25. And sorry I didn't write that very well. It's written better here. We would say that that thing is equal to 25. All right, I'm going to do at least one more example like that. All right, so I'm going to do one just like it, except with a different input number. So let's do, I don't know, f of g of 6. All right, and let's see if you want to pause the video and see if you can make sense of this. That'd be great. All right, so again, we're going to start on the inside and just do g of 6 on its own, which would mean put a 6 into the g function. Okay, and what the g function does with its input is adds 3. So I'll get us 9. So it'd be correct to say that g of 6 is 9. So once we figure that out, then it's going to be f function of 9. All right, and so that 9 now becomes the input, right? G of 6 is 9. So that becomes the input into f. So we're going to do f of 9, which squares the 9 and gives us an output of 81. All right, so overall the way we write this is f of g of 6 is 81. All right, so that's an example of a composition of functions where we strung the two functions together. We do the inside function first, pass that output into the input for the second function. Okay, so now the really complex thing is, so far the first two examples I did here, we put a number in, f of g of 2 and f of g of 6. But now I'm going to do f of g of x. Okay, so that this is kind of like the general case. So f of g of x. All right, and so what this means is, since there's no number in here, it means pass the entire g of x function into f. All right, so we don't have any specific input here. It's just whatever, just doing x. And so we're going to take our whole g of x function, which is this, right? So we're going to say, all right, we have this function x plus 3, and we're going to pass that whole function in, right? That's what g of x is x plus 3. We're going to pass that whole function into f. So we essentially are going to be doing f of x plus 3. All right, and what the f function does is it doubles your input. So in this case, we're going to take the g of x function, not doubles it, sorry, squares it. So we're going to take our x plus 3 and square it. All right, and so this would become a FOIL question, x plus 3 times x plus 3. And then we would FOIL that out to be x squared plus 3x plus 3x plus 9. Multiply all the parts, and so you'd have x squared plus 6x plus 9. Okay, so the way we write this is we say f of g of x is equal to x squared plus 6x plus 9. So when we pass the g function into the f function, we get that as our output. Okay, so there's kind of roughly two types of questions. The easier ones are where they give you an input number and you just find the overall output by doing the composition. And then this type says pass the whole function into the other function and see what the function looks like after that. All right, a little bit of notation. So they're going to use this little open dot notation, right? So basically, I've been doing them the way it looks on the right, which is the way I prefer, because you do the whatever one's here first, and then do the other one second. But please know that if they write it this way, I just kind of switch it to this form. So it's actually the second function goes on the inside. You do that one first, and then you take that output and pass it into the back function, in this case, g. Okay, so yeah, so I've jotted down these notes. And also, please note that they're not the same, right? The order does matter. So g open dot f of x can oftentimes be different than f open dot g of x. And that should be an open dot there, right? They use that little open dot to denote composition of functions. And again, I take these and write them in the other form. So this one's going to be g with f of x on the inside. So f of x is going to come first, then into g of x. And when it's written this way, the g of x goes first. Whatever's here is first, and then that output goes into f of x. All right. So before we go on too much, please note that this solid dot means multiply. So like this would be one from yesterday where we would take the f function and multiply the g function together, right? So we'd go like that, and we would have 6x squared minus 15x. That's multiplication, and then the open dot is composition. So what this one would say here is we want to do the g function first of 7 and take whatever answer we get there and pass that into f. So in this case, g of 7 would be, let's see, g of 7 would be 2 times 7 minus 5. So 14 minus 5 would be 9. So that'd be 9. And then we take that into f, which just multiplies by 3. So f of 9 is 27. So our overall answer to this thing is 27. All right. So this slide, if you can get this, we should be in pretty good shape. So see if you can make sense of these three questions here. All right, hopefully you've tried it. So f of negative 3. So whatever one is closest goes first. So we're going to do f of negative 3 and then put that answer into the g function. So f of negative 3 would be negative 3 minus 5, so negative 8. All right, so we evaluated that first one, and then the output for that becomes the input into the second one. So now we're just going to square. So we're just going to square negative 8, and make sure you use parentheses. Negative 8 squared would be 64. So our overall answer to that first one, 64. All right, so now we're going to go in the reverse order. So now this one, g goes first. So g is going to be on the inside. And then we're going to take the answer to that and put it into f. So g of negative 3 would just square the negative 3. So that would be 9. Again, negative 3 times negative 3. And then f of x, let's see, f of x just does the input minus 5. So 9 minus 5. And our overall answer, f open dot g of negative 3 is 4. 9 minus 5. Again, that should be an open dot. Sorry, doesn't look very open. Okay, and then the last type again is the trickiest type, where in this case we're doing g. I'm going to write in the other notation of f of x. Okay, so we want to pass the entire f of x function into g. So sometimes the way I write this is I just say f of x is equal to x minus 5. Right? That is what f of x is. So I just replace it with that and then pass that whole thing into the g function, and the g function just squares its input. So I just have to do x minus 5 squared. And I'm kind of running out of time, but you'd FOIL that again. You'd have to do x minus 5 times x minus 5. Sorry, I ran out of time, but that would come out to be x squared minus 10x plus 25. So we'd say that g open dot f of x is equal to that. All right, big summary of this lesson then is function operations. The previous lesson we did add, subtract, multiply, and divide. Today was the new one, the open dot called composition of